Okay, so number one, we're subtracting, we're looking for like terms. We only have one x cubed term, so that one stays as is. X squared is right here, but it does say minus. X's, I have a negative 2x minus 5. Negative 2 minus 5 is negative 7. 1 minus negative 7, that's like plus 7. 1 plus 7 is 8. Number 2, we have to distribute. So multiplication, 2x to the 6th plus 5x to the 4th minus x cubed minus 12x to the 4th minus 30x squared plus 6x. Combining like terms, 2x to the 6th. I have 5 minus 12 is negative 7, x to the 4th minus x cubed minus 30x squared plus 6x. Distribute again here. 33x to the 4th minus 22x to the 3rd plus 30x to the 5th minus 20x to the 4th minus 12x cubed plus 8x squared. Look to add like terms. Largest coefficient was x to the 5th, so I should start with that term. And 33 minus 20 is 13, x to the 4th. Negative 22 minus 12 is negative 34, x to the 3rd, plus 8, x squared. Number 4, I have a lead coefficients laid out here. Because it's x minus 2, I have to put a positive 2 up there. Drop the first number down, multiply by the number in the box. 1 times 2 is 2. Add that with the 4, we get 6, and then repeat. 2 times 6 is 12. Negative 9 plus 12 is 3. 3 times 2 is 6. 10 plus 6 is 16. It was x to the 3rd. I divided by an x, so that would leave me with an x squared. So 1x squared plus 6x plus 3. And then that last one is a remainder. Write it in fraction form. The remainder goes on the top. What I was dividing by, x minus 2, has to go on the bottom. Number 5, lead coefficients are 2, 1. Well, notice we're missing the x term, so we had to have a 0 there. And then 1, negative 1 has to go in the box. Bring down the 2, multiply by the number in the box. Add, multiply, and add. We get a remainder of 0. Since the remainder is 0, I don't have to write it. So 2x squared minus x plus 1. Describing end behavior. End behavior always starts off with as x approaches negative infinity, f of x approaches something, and then as x approaches positive infinity, f of x approaches something. We have to fill in the blanks there. So on the test, it'll give that to you. So as x approaches negative infinity, that's the left side. Look at the left end of your graph, it's pointing down. So f of x is approaching negative infinity. Then look at the right side, it's going up, so f of x is approaching positive infinity. We can do number 7 real quick. The left side is going down to negative infinity. The right side is also going down, also negative infinity. Part B, 6 is odd since one end's up, one end's down, while number 7 is even because both ends are pointing the same direction. Number of real zeros, that's x-intercepts. 1, 2, 3, 4 on number 6, but only 2 on C, or on number 7 rather. D on number 6, positive or negative lead coefficient. Look at the right end. The right end is going up, so it's positive. Number 7, the right end is going down, so it's negative. Estimate real zeros. So x-intercepts once again, but this time estimate. So I would say the one is about negative 1.2, and the other one is 0. While on number 9, we only have 1. I would say it's about negative 1.3. For estimating coordinates of turning points. So there's a turning point. So we could call that maybe negative 0.5, comma, negative 3.4. We are supposed to state whether it's a relative min or max. That's at the bottom of a valley, so that's a min. The next one, maybe just slightly to the right of 1, so 1.1, I'd call it, maybe 4.5. And this one is a max, because it's at the top of a hill. Next one, a little to the right of 2, maybe 2.3, and maybe 1.6. Bottom of a valley, so that's a min. If I look at number 9, it's a turning point up there, so 0, maybe 6.5, and it's a max. And then there's another turning point there, so that's 2, probably 2.5, and it's a min. Part C, determine smallest possible degree. So that's the number of turning points plus 1. Number 8 had 3 turning points, so 1 more than that is 4. Number 9 had 2 turning points, 1 more than that is 3. Domain, what x values can be graphed? For every polynomial, that will be all real numbers. Range, that's going up and down. This first one, number 8, goes up forever, but it has a lowest value of about negative 3.4. So f of x was greater than or equal to negative 3.4. Number 9, this one, it goes up forever and down forever, so it's all real numbers. Let's look at the next page. Now we're going to sketch some graphs. They don't have to be exact, but they do have to have certain properties. Okay, so this first one has zeros or x-intercept at negative 2, positive 1, positive 5. Those are the only x-intercepts. Positive leading coefficient means the right side is pointing up. So if I go to the right of 5, it points up. The degree is 3, which is odd, so the left end points the other direction. It's going to point down. And because the degree is 3, there should be 2 turning points. So there's 1 turning point and a second turning point. Number 11, 1 real 0 at 4. Negative lead coefficient, that means to the right of it, it's got to go down. It's odd, so the left side is going up, but it is a degree of 3, which means I have to have 2 turning points. So I can't go straight up and make it a line. So somewhere I have to turn and turn back up, not crossing the x-axis again. It is possible I could have passed through my negative 4 and then had a little turning thing down there. That would have also been okay. Number 12, degree of 4, let's see, real 0 is at 0 and at negative 3. Positive lead coefficient, so right side is going up, is a degree of 4, so the left side is going the same direction. Degree of 4, so 3 turning points, so we have to go down and turn up, back down, back up. Could be something like that. Number 13. Negative 5, negative 4, negative 1, 3, 5, 7, negative lead coefficient, so the right side is going down. Degree of 6, so there should be 5 turning points. I also see there's already 6 zeros. Shouldn't have to add any extra bumps, just wiggle your way through. 1, 2, 3, 4, 5. Since it was, I didn't even point out, since it was even, the left side should have pointed down. It did end up that way. We knew that had to be the case though. So now solve by factoring. We need 2 numbers that multiply to negative 12, add to negative 4, positive 2, negative 6. Set each factor equal to 0. and solve. Square root. Then you have to do plus minus also. Square root of -2, you can't leave the negative in there, instead we get an I. Plus minus square root of 6, that doesn't simplify. So there are my 4 answers. Number 17. Feel like, okay, sorry. What do I get? Plus 6 minus 4. So I square root of 6. And here plus minus 2. So there's our 4 answers there. I just noticed, for some reason, I don't know what happened to this sheet. This sheet is not the exact same one you were given, because there was a 14 and a 15 on the sheet you were given. There's not one here. I don't know why that is the case, but let me talk about those. Okay, so those should have been there as well. It just says to factor. You have to think of this as the cube of x minus the cube of 4. So use your factoring pattern. X minus 4, x squared plus, multiply them together for 4x, plus, and square 4, you get 16. Number 15, first you're cubing two things. You're cubing 3 and y, and then here you're cubing 2. So your 3y is your a, your 2 is your b. Follow your factoring pattern for sum of cubes. Last one was difference of cubes, this one's sum. So it should say 3y plus 2. You have to square the a, square the 3y, square the 3 and the y, minus, now multiply 3y times 2, that's 6y, plus the square of b, 2 squared is 4. All right. Number 18, 19. Given a polynomial, one of its factors, find the remaining factors of the polynomial. So it should have a positive 3 there. Drop your first number there. So we get x squared plus 4x plus 3 is what's left. And then I have to find the remaining factors. I have to try to factor that. So now find all the zeros. Well, don't forget the 3, the one we started with up here. And then if x plus 3 equals 0, we get -3, so that's 1. And if x plus 1 equals 0, we get -1, that's 1. So there are all of our zeros. Number 19, we have a -4. Drop your 1. Giving us x squared minus 2x minus 3. And I need to try to factor that. Factor that. Okay, so now we need to list all of our zeros. I don't know why, I guess I put all those equal zeros in there. They weren't there in the original problem, but we're just trying to factor. Now the zeros, don't forget the -4 that we started with up here. And then I get -1 and +3. When I get to numbers 20 and 21, they do not give me any zeros. So this is where I need to graph it. On graphing calculator Desmos, I'm going to switch over to Desmos. Okay, here's the first one. Looks like we have an x-intercept there at -2 and there at +2. So let's take those and transfer them back over here. So remember those? So since those are zeros, we can synthetically divide them. Pick one. Let's just go with -2 first. So 1, -6, 6, 24, -40. You should get a remainder of 0. We did. Now instead of rewriting that, we can do synthetic division to that. We have a +2. Was the other x-intercept we got from Desmos. So now I got those out of there. What I'm left with is x squared minus 6x plus 10. I'm trying to solve that, so let's go ahead and set it equal to 0. This one is not factorable, which doesn't surprise me because I didn't see it on the graph. Since our graph only gave us, let me go back to it. Since the graph only gave us 2 x-intercepts, even though it was a 4th degree polynomial, go back here, notice degree of 4, and it only gave me 2. I'm expecting 4 answers. That means the missing ones have to be imaginary. So we're going to solve this either by completing the square or by quadratic formula. I think most of you preferred quadratic formula. So negative b, so -6 is +6 plus or minus the square root of b squared. It becomes 36 minus 4 times 1 times 10 all over 2 times 1, which is just 2. So we get 36 minus 40, that's -4. So it's 6 plus or minus 2i all over 2. I can divide everything by 2. So my zeros I had, remember the -2 and the +2 I started with over here. And now I'm adding to it. This would simplify, divide everything by 2, 3, 1, 1. So that could be written as 3 plus or minus I. Number 21, look at the graph again. Graph this. Got it over on Desmos. Here it is. X-intercept looks like only one of them at 1. The others must be imaginary. So we've got a 1. So we're going to synthetically divide that out. And so now I'm going to solve this. So x equals 2 plus or minus the square root of 4 minus 4 times 1 times 7 all over 2 times 1. So I have 4 minus 28. So should we get -24 then? So square root of -24, I can divide out of 4. So I can think of this as square root of 4 and square root of 6 and then an I. So square root of 4 is 2, so I get 2i, and then the 6 is stuck in the square root. And I can divide all of those by 2. So my zeros, don't forget the one I found by graphing, 1. And then I'm left with 1 plus or minus 1 I squared of 6. I can just write the I squared of 6. It's over 1, so I don't need the fraction. There are my 3 zeros.